Session 7 relates to materials. So in terms of a green home, what are you going to build green homes out of? And you know, I think traditionally there was a bit of a view that if you're building a green home, it's made out of straw bales and rammed earth and, you know, all this kind of weird and wonderful materials. Actually, that doesn't necessarily mean to be the case. And one of the key messages, I guess, or key approaches to green homes is that it can look like a completely normal home. Now, for a lot of people that won't matter, but for another lot of people, they really want a home that fits with the neighbourhood and blends in and has a certain look or appeal that they've grown up wanting all their life or whatever. Anyway, the point is that you can use very standard materials and still have a green home. It's just in how you put them all together. And so this section is about, I guess, how you make the best use of the materials you do use, but also to talk a little bit about some of the properties of materials that you're looking for. Now, the first thing to consider here is the embodied energy of a material that goes into a home. And what that means is, what has it actually taken for the planet to produce that substance, to ultimately get it onto your worksite? And different materials have different values. And why it's important is because if you're trying to minimise the environmental impact of this home, then you should choose materials which have low embodied energy. So let's talk that through. Now, if you're using steel, for example, steel has to be mined as iron ore somewhere. It has to be trucked or trained or whatever to a smelter, which takes a lot of energy to process that and eventually turn it into steel, which is heavy to transport. And then that gets shipped a long way around the world as well, and then rolled and refined and eventually turns up on site. So it's cost the planet quite a lot in terms of energy to get that product to you. However, once it is there, it might last a very long time. It might actually be the best possible material because it's actually better in the context. You know, a smaller section of steel will take a greater load than timber, for example. So it might still end up being the best product, but it's used a lot of embodied energy to get there. And then we'll talk about what happens afterwards down the track. Compare that with timber, for example, which if you live in a forested region might simply have come from over the other side of that hill where a tree grew for 20, 30, 40 years, however many, got chopped down, milled into usable chunks, another tree grew in its place. So at a very low cost to the planet and turns up to the home to do the same kind of thing. So it's possible to do the analysis right across the home for all of the components that go into it and choose materials that have the least environmental impact. Now, usually it ends up being a bit of a compromise. So aluminium is a classic material, for example, that takes enormous amounts of energy to refine and lots of transport, but is in fact an awesome product in that it's durable, it lasts a long time, and then it's very recyclable. So there's always a trade-off. But I guess as a builder, we just want you to be thinking about that, and your clients may come through the door saying that that's a really important issue to them, and they want to know that you can hear them in that and say, yep, well, if that is an important issue for you, we'll put extra effort into understanding the embodied energy. Now, I briefly mentioned there, well, what happens with the material after you use it? Well, there's this other thing called life cycle analysis, and that mostly occurs, I guess, in universities around the world, but that's where they look at products in terms of the whole life cycle. So where did it come from? I mentioned steel, so it had to be mined as bauxite, that's aluminium. Steel as iron ore. Where is that mine? You know, does that come from a mine that causes environmental pollution? I mean, there's plenty of examples of materials where mining companies have gone into developing countries and not upheld the same sorts of standards of extraction that we have here in the West, and in fact made life a lot harder for the local inhabitants and polluted the environment. Well, we'd rather not be part of that. Then there is the materials use. Is it appropriate? Is it going to last a long time or a short time? So, for example, if you're going to cause that damage and that social disruption to mine a material, use it for 2 minutes, for example, in a can of soft drink and chuck it away, well, that doesn't seem right, you know, like we've caused all this disruption just so I can have a drink for 2 minutes and chuck it away. Like, well, compare that to, say, using the same product in a window frame that's going to sit and protect the house and its occupants for 100 years. Well, it feels like a better use of that material. So there's the use of the material at the time. The other component is what's happening when you use that material. Is it slowly degrading and releasing toxins like microplastics, for example, into the environment? And then finally, what happens when that material is finished with? You know, can you recycle it again? So, for example, you might have used the can for 2 minutes to have a drink, but if that goes straight back into making another can, well, that's not as bad as if it goes straight into landfill, for example. So that whole process is called life cycle analysis, and along with embodied energy, it becomes part of a decision-making framework, if you like, for building a home that doesn't cost the earth. It's not the sort of thing that I think as a builder you need to get bogged down into, and you can wring your hands and be go in circles trying to find the right answer. And very often I get questions about, well, is it you better off to have a tile roof or an iron roof, or is this tile better than this one? And sometimes it's hard to come up with an answer. But as a general principle, the less processing a material has had, the better. The more local a material is sourced, the better. The longer lasting a material is, the more durable it is, the better. So if you kind of keep those three core concepts in mind, then you're on the right sort of track, you know. So if you can line a house in timber that's been milled locally and looks good and lasts well, and you don't even paint it because it's a lovely grain and it's, you know, then that's much better than using a manufactured product that's been shipped halfway around the world simply to put up on the wall. So that's what we mean in terms of life cycle. The other component is toxicity, and unbelievably in some ways, many of the products that we use in homes these days are actually quite toxic. Paint, although the industry is moving a lot now, but it's one that's been for a long time really not healthy for occupants. I mean, the early paints, perhaps, you know, back in the 20s, and that had high levels of lead in them. And as it turns out, as it broke down over time, you know, the occupants of the house were breathing that. If you were touching that paint, it was absorbing into your skin. And lead, like many heavy metals, are not good for humans. So, and recently though, there was a development in a whole heap of what would you say, you know, acrylic paints, and some of the hardeners that they used in those were very effective, but actually the gases that they give off. So, you know, paint is liquid, and then the reason it goes hard is because that liquid evaporates off. You know, it disappears. Well, as it turns into a gas and evaporates, which is that smell you get when you paint, you know, those gases are now known to be carcinogenic in many instances. So, and not just when you're painting, but in the weeks and months after that painting has occurred. Well, you don't really want to. If someone asks you, you wouldn't say, yeah, I'm just going to, if you don't mind, I'm just going to fill your house with cancer-producing gases for a few months when you move in with your young family. And I mean, that's madness. You wouldn't do that, right? But we have been for many, many years. So fortunately, you can now get products which have been designed not to do that. So, you know, 2 days after you've painted, you won't smell it. And in the longer run, it'll be a very, very low risk for the occupants of the home quite quickly. Now, it's like that in many of the components of building, and one of the things we do in the assessments is kind of teach you guys to select those products that have the lowest level of toxicity. And I know from experience, when you do that, from day one when you walk into the building, it feels fresh, it doesn't smell, and is automatically kind of much more homely. It doesn't have that, you know, like that new feeling of say a car. You know, people go, oh, it's got that new car smell. Actually, that's quite poisonous. You know, you don't want the new car smell. Anyway, so you do the same with everything that goes into a home, and you end up with a much more healthy living environment for the occupants. The other thing, I guess, moving away from those elements is just the functionality of the materials you use, and there's something to be said for doing a fair bit of research in this and actually finding products that you know and you like to work with and that work well. So examples of this have been mentioned previously, you know, different types of cladding and lining, but the most important thing is that is to know that there's not one size that fits all here. It really does depend a little bit where you are and what the what the tastes are of the client that you're building for. But you need to pick materials that actually meet the brief and meet the function kind of first. And then the final thing we want to look at is the durability of materials, which I guess is tied into that function. So we've seen a lot of composite materials enter the market that are really easy to machine and work with, but many of them, the moment they get wet, you have to rip it down and put a new lot in. So, you know, a classic example of that is skirting boards. If you have a solid timber skirting board, then and you have spillage of pipe bursts or whatever, then that skirting board will be fine. If you have a composite product one, it will swell and disfigure, and you have to chuck that out, get a new one in, so which is all time and money and impact to the planet. With green homes, you know, we take the view that the home should stand for, you know, decades and perhaps even hundreds of years. And when you do that, it's a bit of a mind shift. You make slightly different choices. It's not about banging up something quickly that's going to last, you know, just to get over the line. It's about, you know, building something that's going to last. And the byproduct of that really is quality. And you don't want to shy away from that as a builder. I think that's a really important message for the clients, is go, no, we're not just banging this up for you. This is a quality, durable, you know, long-lasting home. And it just happens to be that that is actually better for the planet as well. If you are going to pour all of these world's resources into building a home, then why wouldn't you do one that stood the test of time and was something that you could hand on with pride to your, you know, future generations?